Hi, welcome back. I'm happy you joined us for a deeper dive into the PCB manufacturing. This training video is meant to help you get a better understanding of how PCBs are manufactured. To do that, let's learn some new terminology and fundamental concepts that will help us understand the process a little better. In the What is a PCB training video, we learned the very basics of how a PCB is made. We learned that a PCB is built from multiple layers of copper and that our base material is a copper dielectric copper sandwich. This means that in one sandwich, even though it looks like one big block, it is actually composed of two separate layers of copper. So when one sandwich goes into the manufacturing process, the machines are working on two layers of copper. But why copper? Copper helps electricity move from one place to another. If you put electricity on a layer of copper, the whole layer will become electrified. Dielectric, however, does not move electricity. In fact, it blocks the electricity from moving. So a PCB is built from multiple layers of copper that are attached and glued to one another. The top and bottom layers are called the outer layers. They are the outside layers that you see in the final PCB. The layers in between them are called inner layers. Those are the inside layers you don't see in the final PCB. Now that we understand that a copper dielectric copper sandwich is made out of two layers of copper, that copper moves electricity while dielectric does not, and that a PCB has outer layers and inner layers, we can start our ride into the exciting world of PCB manufacturing. We start at the pre-production engineering. When the order is sent out to our manufacturer, their engineering unit will look at the order, compare the files to the specifications, and make them ready for manufacturing. In the factory, everything starts with the base material. Our manufacturers do not produce the raw materials. They receive them ready-to-go sandwiches, copper, dielectric, copper, from an outside supplier and store them in their factory. There are different varieties of sandwiches, which are organized by the thickness of both the copper and the dielectric. Some sandwiches will have thick copper, others will have thin copper. Other sandwiches will have thicker or thinner dielectric. The manufacturer will choose the right sandwich for every layer based on the customer's specifications. After choosing all the right sandwiches, the inner layers are produced first. This is the stage where we want to make the big block of copper become like small copper wires, where electricity will be moved according to the client's specifications. But how do we change this big block of copper into small copper wires? We need to get rid of all the unnecessary copper and leave only the right amount of copper on the sandwich. We do that by removing all the unwanted copper with the help of a special solution. But how do we keep the right amount of copper on the board? By protecting it from the solution. In order to protect the right amount of copper, first, the whole block of copper is covered in a material that is very sensitive to light called photoresist. This process is called lamination because our sandwich is literally laminated with photoresist on both sides. Photoresist under exposure to UV light becomes thick and hardens. So when UV light is exposed to copper with photoresist on it, the photoresist becomes hard, like a shield, covering and protecting the wanted copper. Once the copper is laminated with photoresist, our photoresist covered sandwich goes into a machine that shoots UV light in the precise pattern that mirrors our client's specifications. Like a stamp on a paper. When you use a stamp, only the part that sticks out will be seen on the paper. This is similar in the way that the UV light is shot onto the photoresist in the exact pattern that is supposed to protect only the copper we want to keep. This process is called exposure because our laminated sandwich is exposed to UV light that is shot directly onto the photoresist, which hardens and becomes a shield that protects the copper we want to keep. After the right amount of copper is shielded on both sides, the unwanted parts of the photoresist must be removed. Our sandwich goes into a special solution that removes all the photoresist that was not exposed to the UV light and did not become a shield. This process is called developing, where we remove all the unwanted photoresist while the shielded parts stay on, protecting the wanted copper, leaving the unwanted copper bare with no protection. Now that our wanted copper is shielded and our unwanted copper is not protected, we can get rid of it. Our sandwich goes under a process called etching, where it is bathed in a special solution that erases all the copper that is not protected. Because our wanted copper is safe under the shield, the solution only clears the copper that is bare with no protection. This is the first time we will be able to see the dielectric in the exact same place where the unwanted copper used to be. Now that the unwanted copper is removed, we are left with the perfect amount of copper, which doesn't need to be protected anymore, so the shield must be taken off. This process is called stripping, where our sandwich goes into a different special solution that strips and clears out all the protective shields. To sum up the inner layer production, our copper dielectric copper sandwich goes through lamination with photoresist, and then exposed to UV light where it receives a protective shield that protects the copper we want to keep. Then, the sandwich undergoes the developing process where the soft photoresist that did not become a shield dissolves, leaving the unwanted copper bare. Next, through etching, the unwanted copper is removed in a special solution, leaving only the protected copper on the sandwich. Lastly, the shield is taken off in the stripping process where the right amount of copper is now left exposed on the sandwich, ready for the next step. Once the inner layers are finished, they are ready to be transformed from being separate lonely layers into one solid board in a process called pressing. At this stage, our manufacturer will start building the PCB tower, layer by layer. In order to glue every layer to one another, a glue-like material called prepeg is stacked in between each layer. Prepeg, sandwich, prepeg, and so on, depending on the number of layers the PCB is supposed to have. The prepeg sandwich tower is pressed together along with two new untouched thin copper sheets that are added on top and the bottom of the stack. You guessed it, those are the outer layers. The prepeg sandwich tower is now stacked in between two new untouched outer layers, which at this stage are just plain copper. Now our tower looks something like this: copper, prepeg, sandwich, prepeg, copper. This tower is a 4-layer PCB, 2 inner layers of copper in the sandwich and 2 outer layers of copper. Our tower is ready to go into a machine that will press the whole tower together under extreme pressure and very high temperature. At the end of the pressing process, the stacked tower will come out as one single board. For the first time in the process, we finally have one board. Now, holes must be drilled through it with different drilling tools. The holes can be of different sizes, from very big to tiny. They can also be drilled at different depth. In one PCB, you can find holes that are drilled straight through the entire board, and also have holes that are drilled only from the top layer to the third layer, or from the top layer to the second layer. It all depends on the client's specifications. Our board has holes in it. Hooray! But in order for the layers that were just drilled through be connected electrically to one another, the holes and the surface of the board must go through copper coating process called plating. The drilled board is dipped in a bath of copper solution, where the surface of the board and the holes are covered with copper, connecting the layers electrically. At this stage of the process, the outer layers, the top and bottom part of the PCB, are just still plain copper surfaces with lots of holes drilled through them. They are now ready to be transformed into small copper wires. Once the copper on the outer layers transforms into copper wires, they will move electricity from the surface of the board to the holes, so electricity will reach all the inner layers. However, the amount of copper our holes and surface have at this point of the process is not enough. More copper must be applied to ensure the right flow of electricity. But how do we add more copper to only the right places? The outer layers go through similar process to that of the inner layers, but with a twist. Our board will go through lamination with photoresist and then exposed to UV light, where it will receive a shield that will cover the the unwanted copper. Wait, what? Stop, rewind. What do you mean shield the unwanted copper? So in the inner layers, we wanted to shield the wanted copper to protect it while we get rid of the unwanted copper. However, now in the outer layers, we're doing the exact opposite, because this time our board will go into copper solution again, where only the exposed copper will receive the extra coating of copper and leave the shielded copper untouched. So after our board goes through lamination and exposure, it will go through the developing process that will dissolve all the photoresist that did not become a shield, this time leaving the wanted copper exposed. The board will then go through the plating process again, where it will be dipped in a bath of copper solution, giving only the exposed copper the extra copper coating, because the copper solution can't stick on the photoresist shield. Now that we have the perfect amount of copper in just the right places, we can get rid of the shielded unwanted copper. So our board must go through the stripping and the etching process, just like in the inner layers, except now our wanted copper is exposed with no shield. If the board was to go through the stripping and etching process right now, we would lose all the wanted copper too. So we must give the exposed copper a protection. In order to do that, our board will go through a tin coating, giving only the exposed copper a tin protection during the stripping and the etching of the unwanted copper. After our wanted copper is protected by the tin coating, the board goes through stripping, where a solution will strip and clears out only the photoresist shield, leaving the unwanted copper bare. Then it goes through etching, where the board is bathed in the solution that erases all the copper that is not protected by the tin. Because our wanted copper is safe under the tin, the solution clears only the copper that is now bare with no protection. Finally, the board will go through tin stripping, where the protective tin will be taken off, leaving only the thick wanted copper on the board. To sum up the outer layer production, the board will be laminated with photoresist, then exposed to UV light that will shield the unwanted copper. In the developing process, the photoresist that was not hardened will be washed away, leaving the wanted copper bare. Next, the board will go through the plating process, where our exposed copper will receive an extra coat of copper, then be dipped in a tin solution to give the wanted copper a protection. So it will be protected when the board goes through the stripping of the photoresist shield and the etching of the unwanted copper. Lastly, the board will go through the tin stripping process, where the tin protection will be cleared, leaving the wanted copper exposed on the board, ready for the next step. Now our board has the perfect amount of copper that must be protected. To do this, solder mask is applied onto the board, a protective layer that keeps the board safe. Solder mask is applied in order to protect the copper from oxidation and to safeguard the board during the assembly process. Usually, solder masks are green, which is what gives the PCBs their famous green color, though solder masks can also come in other colors. Next, legend printing. Text and patterns are applied on the board after the solder mask according to the customer's needs. For example, legend printing can help our clients assemble components on the board or help them understand the age of the board by adding date codes. After legend printing, another protective layer called surface finishing is applied to the board. Surface finishing can be done with lots of different resources. It all depends on the client's type of business and the way that they will place the components onto the board. Each surface finishing has its advantages and disadvantages. For instance, immersion gold has longer shelf life, which means it is more durable, but also more expensive. On the other hand, immersion tin is cheaper, but handling it can be sensitive. After surface finishing, our board is ready to be cut out of the production panel in a process called routing. The panel will go into a machine that will cut the PCB according to the client's exact specifications. After that, the electrical test. Each board will go into a machine that will make sure that it is running smoothly with no shorts nor opens, and to confirm that everything is connected and working correctly. The electrical test machine will read the original files and will check the board's holes one by one to see they are all functional. Throughout the whole manufacturing process, there are visual inspections at almost every stage. But the final visual inspection checks the final board surface to ensure there's no damage like scratches or small dents, and to see that the surface finishing and the solder mask are evenly spread over the board and cover all the right places. That's it! We made it to the finish line of the process. As we have learned, manufacturing of a PCB has multiple stages, some of which are more complex than others. To sum everything up, in very short, the manufacturer receives the relevant files, makes them ready for manufacturing, and sends them to the factory. At the factory, the right sandwiches will be chosen and go into the inner layers production. After the inner layers are ready, they are pressed and glued to one another, along with 2 new outer layers. The multi-layer tower becomes a single board and undergoes drilling and copper plating, followed by the production of the outer layers. Solder mask is then applied onto the board with legend printing, adding text and symbols onto the solder mask. Then, the board goes through the surface finishing process, giving it another protection. Lastly, the board is cut out from the production panel and goes through the electrical test and the final visual test. We hope this training video helped you understand the process a little better. Next up, coffee. Thank you for listening.